Good afternoon, my fellow classmates. As you all may know, my name is Amonike, and I am here with Tor Nilsson to discuss the topic of the effects that nuclear energy slash waste has on the environment. Nuclear, nuclear energy has multiple adverse effects on an individual cell. The process of nuclear fission and its byproducts emit ionizing radiation in the form of alpha, beta, and the most deadly of all, gamma particles. Gamma particles have the potential to damage, change, or even destroy a cell's DNA and proteins. This means long exposures to gamma radiation can lead to cancer and death. Nuclear waste, as well as emitting radiation, contain highly toxic chemicals like plutonium that, once ingested, lead to a slow but inevitable death. For example, the ex-Russian spy Alexander Litvinenko was poisoned with plutonium and finally died after 3 weeks of the poisoning. Nuclear energy has both positive and negative effects on the environment. Because current nuclear waste stay in the environment for tens and thousands of years, it can majorly disrupt an ecosystem. Nuclear catastrophes like Chernobyl have the potential to disrupt or completely destroy an ecosystem. While nuclear energy can have a downside, it helps cut back on greenhouse gases, preventing global warming, acid rain, and lung diseases. Nuclear energy can produce amazing amounts of energy, up to 54.68 megawatts, cutting back on the use of fossil fuel, and in turn further cleaning our atmosphere. Now on to Tor.
Nuclear energy, while producing an enormous amount of energy, its byproduct, nuclear waste and plutonium, are extremely dangerous. Plutonium, while can be used to create enormous weapons of mass destruction, nuclear waste can stick for tens of thousands of years in the environment, irradiating it and completely destroying it as a result. While there are many possible known solutions to the problems of nuclear energy and its waste. One very reliable one is renewable energy sources. These sources like wind, solar, and water flow provide a clean but expensive source of power. The real problem with renewable energy sources is that it is very costly and you need a specific environment in order to get sustainable amounts of energy. Our next possible known solution is the liquid fluoride thorium reactor, or LFTR. Thorium is another radioactive element that, while still radioactive, is less radioactive than uranium and plutonium. Its reactor, using a bunch of fluoride-based salts, can provide more energy than a uranium reactor, and its waste only lasts up to 300 years. The big problems with a liquid fluoride thorium reactor is that, if built incorrectly, can lead to humongous disastrous results, and is very expensive to currently construct one. Our possible solution is that we use a nuclear fusion reactor. A nuclear fusion reactor uses the element hydrogen and fuses it together into an isotope of hydrogen known as deuterium. It then fuses deuterium with another element of hydrogen to form helium. This reaction produces an enormous amount of energy that dwarfs the nuclear fission process that we currently use today. It is the process that is currently used in every star that we see, and can be a very huge possible source of energy in our future. I said future because we can't currently contain the massive amounts of energy produced by said reaction. So currently it is a bright idea for the future, but not for the reality of now.